Good evening. Right. So this is our second question of our physics daily practice program, right? So now this question, which I sent you, this is a Morato paper question, right? Morato question, right? So let's see. Now, first of all, try to understand the question and try to connect what are they trying to actually test from us, right? First, you should, by reading the question, you should understand what are the laws we can apply, what are the equations we can apply, and what are the concepts we can apply, right? Okay, let's read the question. Consider that the speed of a wind blowing near the earth's surface is proportional. ah, they have used a word called proportional to the height. It is proportional to the height. Which is proportional? The speed of the wind is proportional to the height from the ground. A wind turbine converts a fixed fraction of kinetic energy of the wind into electrical energy. Turbine is converting kinetic energy from the wind into electrical energy. It seems okay. If the electrical power output of a turbine is 15 kilowatt, okay, the power output when it is installed at a height of 10 meter, when the turbine or the wind turbine is 10 meters in length, the work output or the power output that has been produced is 15 kilowatt, it seems. Okay, what is the electrical power output when it is installed in height of 20 meters, when the height is doubled? Okay, let's see how to do this question. Okay, right. Now here we know that after reading this, what are the concepts that are involved? First, let's don't keep on wasting your time writing what are the concepts involved, right? Now, as this is a revision program, I'll revise what are the concepts, no, how to approach a question, right? Okay, what are the concepts here? First, the concept of power is involved. Yes. Second one is there is something called energy. Kinetic energy is converted to what type of energy? Electrical energy, right? So energy is involved here. Okay, energy is involved. Okay, what are the other things that are involved, right? I hope those two are involved mainly. Let's see when you're doing the question, are there any other things that are involved? Okay, so what are they first saying us? Right now, let's try to draw an image and try to approach the question. Right, they are saying something like a wind turbine. Let's take something like a windmill. Right, there is something which has a height of 10 meters. This is the height, right? What it does, it has a fan like something, right, which it rotates, right? So when there is a wind that flows, it converts that kinetic energy into what type of energy? Electrical energy, right? Okay, so from that what happens, there is a power output. The power output is 15 kilowatt. Is that clear? Now you should understand what have they said from the example. They have given one instance, right? That is this instance. See now, they have said there is a 10-meter height turbine and it takes the wind, and from that wind, when there is a wind that flows, it converts that kinetic energy into electrical energy, right? Let's see. Can you see? This is what they have said. Okay. Now, what is the question they have given? They have said the question is when the height is doubled, something like this, right? When the height is doubled into 20 meters, they're asking what will be the power output. Now, we can't just say that it is, as it is double, it should be 30 kilowatt. No, in physics we can't do those calculations. We should do the actual equations that we should apply for them, and we should identify what is the answer. Let's see. Right now they're asking what is the power. Let's see. Now before going on to this, now can you understand here, they have used a word called, see here, where now if you see there's a fixed fraction of kinetic energy, and they have converting that kinetic energy into electrical energy. Okay, now can you see there's a flow? Now what happens, there's the wind, what happens to the wind? The wind flows, right? The wind flows. This word is very important for this question. Wind flows. Now, this is from basic knowledge. They haven't given the word flows, but we know that wind would flow. That wind flows, and what happens? That wind flows, so there is a kinetic energy that is generated. That kinetic energy is converted into electrical energy. That electrical energy gives an output of 15 kilowatt. That is the scenario. But we should understand that there is a kinetic energy that is created due to the wind flow. So wind flows. Okay, so now we might ask, so okay, wind flows, but what is that hint that is giving? So from the word flows, what is the hint they are trying to give? They are trying to give something called there's a flow taking place. What flow? Have you heard something called? Now normally I'll give you the basic equation, right? Right, I'll introduce you for the basic equation. We know that there's an equation called density equals mass over volume. Even a small child would know this. So we can use the equation. We can change the sides, and we can get an equation like this: mass equals density into volume. Now, what if we divide right hand side and the left hand side by time? We'll be getting mass over time. Density over time we can't take it because density cannot be divided by time. So we can take density and volume divided by time. Right? Okay. Mass divided by time is called mass flow rate. Right? Mass flow rate equals to density into. Here's the new equation. Now, let's see. Volume flow rate. What will be its units? What will be its units? Volume flow rate. Volume divided by time. Volume. For volume, what is the unit? Meter cube. Am I right? Time, seconds. So eventually we get the equation, sorry, the unit m cube is minus 1. Right? Okay. Now I am saying that instead of volume flow rate, we can use surface area into velocity. But so, how did you introduce that? Let's see whether the units are the same. Now I'm saying instead of this volume flow rate, we can write surface area into velocity also, right? Let's see whether it is matching. Surface area, what is the unit? Meter square. Velocity, what is the unit? Ms minus 1. So meter into meter square equals meter cube. S minus 1 equals S minus 1. So let's see. Both of them are matching, right? Now, so we can say, now can you understand? Instead of writing mass flow rate equals density into volume flow rate, we can write a new equation called mass flow rate equals to density into surface area into velocity. Is that clear? This is an important equation. Right? Right? Okay. Right. This is a general idea. Right? Okay. Let's get back to the information they are saying. They are saying that the speed that flows is directly proportional to height of the the turbine from the ground. The velocity that is flowing, this velocity is directly proportional to height. Okay, it is directly proportional to height. So let's write that also. The velocity is directly proportional to the height. Right? Okay. Now, first they have said the power they have given the height, right? Let's try to, use this equation and find, right? Power, height. They have given two, power and height. Let's see to connect these two, the power and the height. Okay. What are the equations we know so far? We know power. Normally we know the equation. Normally people would use the equation power equals work done over time. Some use the equation force into velocity, right? There is another equation where power, power's uh, units are watt, joules per second. joules per second. So we can write it as energy over time also, right? Energy over time. Energy over time, right? Energy over time. Okay. So they have said now this is one equation, right? So power can be given by these three equations: work divided by time, force into velocity, energy divided by time. Okay. Now let's go to the actual idea, right? Actual idea is they are saying the kinetic energy is converted into electrical energy. Electrical energy. Kinetic energy. Kinetic energy is given by half m v square, right? Electrical energy. I'll give the word E, electrical energy. Okay, now so you might ask, how can we connect here power? We should connect power, right? So here, check how can we connect. If we introduce a time to this equation, we can connect. Let's introduce. Let's introduce, right? What shall we do? We'll divide both sides by time. Half mass flow rate. Why? Now, if I divide it by time, it will be giving mass flow rate, right? V square equals to energy divided by time equals to power. See here, I have given it here. Right. Now can you see we have got a new equation, right? No, I said that power has only three here, but see here we have got a new equation. So instead of mass flow rate, also we can use what? There's another equation here. See here, mass flow rate equals to density into surface area into velocity. Let's use that one here, right? Half into density into surface area into velocity square into rho. So velocity into velocity square, it will be velocity cube, v cube, right? ah this is the equation we use for for the uh, for this question, right? Now here see we have derived an equation. They haven't given this equation, we have derived it. You might feel, sir, how can we do it now from the here? Let's see. ah Now you might ask, sir, here there is no height here, how can we do there is height here involved, how? For that only they have given this hint. What was the hint? Where is the hint? They gave a hint. Here velocity is directly proportional to height, it seems. See here, velocity is the speed. Speed means velocity, right? Velocity is directly proportional to height. So can you understand? Instead of v, we can write h. So instead of v cube, we can write h cube, right? Okay. So we can write here power equals half into density into A, which is the surface area, into h cube. This is the ultimate equation which we use for the calculation in this question. It's not really hard, right? We should give a try here. It's not really hard. As this is the first time, it might feel we have gone so much of, right? No, it's easy, right? No, with practice we can just get them, right? Okay. Now this is the equation we'll apply for the two instances. What are the two instances? For 10-meter height and for the 20-meter height, right? Okay. Let's apply it here, right? I'll apply it something like here, right, with the equation, right? Okay. So for the first instance, right, power was 15 kilowatt, right? Half density will be the same. Why? The air which flows is the same, it does not change, right? Density is the same, area is the same, right? Why? The turbine area, the surface area that has been occupied, does it change? No. What is changing actually? Actually, the height is the one that is changing. So initially the height was 10 meters. So 10 to the power cube. This is the first equation. So now they are asking what is the new power? New power half into density into surface area into height. Now the new height is 20 cube. Now to get the P, we can divide 1 by 2 or 2 by 2. I'll take by 2 by divide second equation by first equation. P over 15 kilowatt, right? Now we can cancel it off, but if it is the first time for you, I'll do it as the long method, right? I'm not hurrying. I'll do it patiently, just to make you understand this, right? Half into D into A 20 cube. So same will be written here. Half into D into A, but the change is 10 cube. So we can understand that. I use another color, right? Half cancels off. D cancels off. A cancels off. Right. Now what actually remains? So let's see. Actually, final it will be remaining is power 15 kilowatt. Now rather than keeping it like this, what you can do? I can change it. How? 20 divided by 10 whole thing cube. Now it was, sir, this is a headache right now. Yes, we can simplify it further. How? We can simplify it like this 1, 2. So if that is the case, P over 15 equals to 2 cube. 2 cube is easy. 2 cube is 2 into 2 into 2. 2 into 2 is 4, 4 into 2 is 8. So answer will be P equals 15 into 8, which is 120 kilowatt. Is there any answer like that? Let's check. Yeah, here is the. Let's see. The fifth answer is there, right? So the answer is answer number 5, 120 kilowatt. Can you understand? No, it's not really hard. What we should have is the actual, the basic knowledge, right? See here. With practice, we can, minimize the steps we do. What are the steps? Now, this is an equation that normally teachers used to teach, right? This is not directly given, but they used to teach it, right? What is the equation? See here. Mass flow rate equals density into surface area into velocity, right? That is one equation, right? These are the equations that are derived for power. This was the equation which we derived now in this equation. Now, don't use this height h cube. We can't use this anywhere. Why? Because they have given in the question that the speed is directly proportional to height. So we used it. But actually, it is not so. Right? Okay. Right? So this is the second question. Now here, I patiently explained you the concept of power, the concept of energy here. Right? Right. So hope you now understood this clearly. So meet you again in the next question, right? I'll be sending questions regularly, so do them, right? So meet you in the next discussion, right? Thank you.